We're going to start our look into the urinary system and start to take a look at how our body gets rid of the wastes that all of our cells are producing throughout the day. And so when it comes to the urinary system, it's a pretty basic system. We just have the two kidneys there and then a way to get rid of the products that it is producing. And so its overall function, though, is quite important in body. So number one function is eliminate waste. And those wastes are our nitrogenous wastes that we have in the body, are the things that it has to get rid of the things that we actually produce. And so there's going to be other kinds of waste, things that we may have consumed, things that we come in contact with, things that are within the body that are there for various reasons, but we have to get rid of them, and they're water soluble, so we can eliminate them through the urine itself. Within the body, we have electrolytes that come and go through our diet. We use them. We have them within the body. We need them. And so things like our sodium, potassium, chloride ions, etc. All of those concentrated ions that we have in the body, we have to regulate whether we have too many or too little. And so depending upon our water content, depending upon how we're getting them in our diet, is going to dictate whether we need to keep them or get them out of the body. As our body is going through its normal homeostatic processes, pH changes. Meals come in, breathing changes, exercise, we're utilizing our metabolism, and pH is either going to rise or fall, and the kidneys have the ability to alter our body's overall pH by altering what's inside the urinary outflow within each moment. Speaking of water, we have the ability to maintain volume. And so as either our volume goes up, so does our blood pressure. As volume goes down, so does our blood pressure. And so plasma volume is going to be related back to our overall blood pressure. And at the same time, the amount of volume that's there also is going to play a role on things like electrolytes as well, in terms of their concentration that's there. Mentioned in terms of eliminating waste, things that may be in our body from foreign processes, namely things like medications, but it could be also other things that are in our food. So just take a look at a list of ingredients in any number of products that you may have in your house, and you're going to see all kinds of things that you cannot pronounce. Some of those are going to be water soluble, some of those are going to be fat soluble, and so we're going to get rid of them in different ways. But when we can, we're going to get rid of them through the urinary system. When it comes to oxygen and the amount of oxygen that we have available to our tissues, the kidneys are where it's at for the production of more red blood cells. And so if oxygen levels are falling, or at least our ability to get oxygen to the tissues is falling, we're going to secrete erythropoietin in order to alter that. Same thing goes for that of blood pressure. And so as our blood pressure is being altered, the kidneys are kind of self-serving in that sense, that they're going to secrete renin, and that renin is then going to go out and eventually lead us to angiotensin 2, and that's going to allow for us to maintain blood pressure. And so the kidneys are going to be kind of self-serving in that sense. They need to have a high blood pressure coming into them in order to do their filtration. And so they're going to have the ability to secrete that renin when it's needed. We've talked in the past about vitamin D and its importance within the body. When we take that vitamin D as in terms of a supplement, it is something that we generally can already utilize depending upon the form of that vitamin D. But when we make that vitamin D as a product of sun exposure, then that vitamin D is in an inactive form. And so we're going to need to have part of the vitamin D activated down here in the urinary system. So as I said, the urinary system is a fairly basic system itself. Remember back to anatomy, we have two kidneys on either side. The left one is slightly higher than the right one because of the liver. And within that, we've got good blood supply coming right off of the abdominal aorta. We have the renal arteries, one on the left, one on the right. And then draining them, we have the renal veins. Once that blood gets into the inside of the kidney, it's going to make its way all the way out towards the cortex. And then the nephrons are going to make their way back down into the medulla. And that's essentially where we're going to do the formation of urine. And then urine's going to end up back out and on out of the kidney. So we have some other structures that we can see here that you remember. We have the renal pyramid, kind of looks like a pyramid when we kind of dissect it all out and around. At the end of those pyramids are the papilla. This is where the urine is going to exit from the nephrons down through the collecting ducts. And then it's going to collect down into the kidney. And as it does so, it's going to go through a minor calyx. Into those minor calyces are going to drain into a major calyx, down into the renal pelvis, and out down through the ureter, down to the bladder. Once that urine, remember, hits the minor calyx and is out into that space there, this is the final product. We don't change the urine at this point. Everything that's coming down from the kidneys into the bladder is simply mixed. And so at one moment, we may be making a high concentrated urine. The next minute, we may be making a low concentrated urine. But as far as the urine goes coming down to the bladder, it's just simply going to mix down there in the bladder itself. And so we're not going to make any changes once it leaves the kidneys. Our representation of the kind of common tubules here. And so we have our nephron. The functional part of our kidney is within the nephrons themselves, and it's served by blood supply, starting out with our afferent arterial. So afferent telling us that it is incoming, so it's going towards something. And so where it's going towards is the glomerulus. And so inside that glomerulus, we have filtration occurring. We're going to filter the blood there. And then outgoing, we have our efferent arterioles. Those efferent arterioles are then going to become the peritubular capillaries. And so our peritubular capillaries are all of the purple portions, and it's surrounding all of the tubules that we have there. Once we've filtered the urine, and the urine enters into the capsule here, it's going to start to travel through the proximal convoluted tubule, all the way down until it gets to the loop of Henle. And so the loop of Henle itself has a thick segment, and then it also has a thin segment. The descending loop here, and then the ascending loop. And then that tubule is going to come back by the capsule again. And this is where we're going to essentially kind of test what's inside there. We're going to take a look and see what's inside the tubules themselves and see if there's anything else that we need to do to it. And so we go through the distal convoluted tubule and then eventually into that collecting duct. And by this point, this is just about our final product. And it's going to head down towards the minor calyx to the major calyx to the renal pelvis. And so that's going to drain out through there. And by the time that we hit the pelvis, or even just once it leaves the pyramid, we now have our final product of urine at that point. So here we have kind of a deconstructed nephron, my little drawing here. And within that, again, the functioning of the nephron is done in a couple of different processes. Initially, we start with filtration. So blood that's entering into the afferent arterial comes into the capillary loops there within the glomerulus and then goes out. What ended up coming into there is essentially all filtered out. And so as much as we can, this is going to exit into the tubules. So it's going to enter into the Bowman's capsule and then into the tubules. We now have essentially everything that can be filtered through. And so as long as it is small enough to filter or to go through the filter itself inside those little capillaries, and remember we have little filtration slips, we have our podocytes, we have the very leaky blood vessels there. All of that is designed to essentially allow us to take out everything except for the larger components of the blood. So whole blood cells, our red blood cells, white blood cells, big proteins, all of that's going to stay in the blood. but everything else is going to come through. And so all of our nutrients, everything that we can get out through there is going to come out and into the proximal convoluted tubule. And as it starts to make its way down through the proximal convoluted tubule, this is where we're going to start to do reabsorption. So we basically dumped everything out, but now we need to get everything back. It's kind of like if you have your school bag, your backpack, something like that, and you dump out all the contents. It's the end of the semester, it's time to clean things up. And as you do so, you just dump everything out. And then you're going to take back the things that you really want. So in terms of the fluid that we just got rid of, we want back the good stuff. We want back the electrolytes that we still need. We want back the hormones. We want back the glucose back into the blood. And so that's going to be reabsorbed. From there, we're going to do, as we kind of continue on down through the loop of Henle, we're also going to reabsorb lots of water. And so as we go through the loop of Henle there and on through, we're going to do some secretion as well. The secretion is going to happen to essentially the things that we weren't able to filter out, we're also going to essentially pump in. And so secretion is going to take substances that are still in those peritubular capillaries. And so our peritubular capillaries, this efferent arteriole comes back around, follows those peritubular capillaries, or becomes the peritubular capillaries and follows the tubules themselves. And from those capillaries, we're moving substances that we have to get rid of. And so we're getting rid of things like the urea, the uric acid, the creatinine. All of those things that we must get rid of out of the bloodstream, we get rid of and we secrete them out. We'll talk about these all in more detail in coming up slides, but just to kind of give us an overview here, we have the functions that are going on. We continue with our secretion and reabsorption. And then we come to the collecting duct, and now we basically have what's ready to be excreted. We may do some final movement of water back in or water into the tubules themselves. We may utilize this in terms of moving urea. And our final product heads on down towards the end of the pyramid. And we now send out that final product. We've secreted or we've excreted now our waste products, and that's now going to leave the body. We finished the process. So we'll take a little bit closer look with a little bit better drawing here. Again, glomerular filtration. This is taking everything that's inside the blood. And as we take what's inside there, that's going to get filtered out. And we're going to take basically everything that we can. As long as it's small enough to fit through the filter, it's going to make its way out at that point. This is a very simplified version of the nephron. We can see our efferent arteriole here is continuing on out and becomes the peritubular capillaries, kind of following the tubules themselves there. We're going to end up doing our tubular reabsorption. So we're going to pull those things back that we want. We're going to get them out of the tubules, retain everything that we need back, whether it be water, hormones, nutrients, anything and everything that we still want, we're going to pull back in through reabsorption. And then lastly, we're going to do secretion. We're going to get rid of those products and pump them from the blood vessels back into it. So this is going to be more of an active process. A lot of times, some of it is going to need carrier proteins and things like that in order to get moved back into those tubules. Remember, if we don't have a particular receptor, if we don't have a particular ability to move that substance, it's going to get lost. And so it's going to end up into the urine itself, and it's going to be lost simply because we don't have the ability to pump it out, and or we don't have the ability to pump enough of it. And so if there's way too much, say, glucose, or concentration of glucose is way high, we may lose that glucose in the urine, and with it is going to go a large amount of water. So we have to be able to reabsorb it. We have to be able to pull it back into the body in order to not lose it at that point. Next up, we'll start taking a closer look at the tubules themselves and the actual filtration process.